In our programming thus far in this course, we have taken a procedural or structured approach to programming, where everything occurs in a group of code from beginning to end, and we basically go line by line. We may have some loops or things that come back around, or some conditions that break off in different forks, but in essence, we're programming one block of code. Now, we're going to make a transition here to creating developer-defined functions or methods. And in reality, we've been using functions all along. And I've mentioned several times along the way that when you see a set of parentheses, you should recognize that as a function. And so we've been using functions such as print. And print takes an argument inside parentheses of what you want to have printed. We've had the input statement, which displays some text, asks the user to enter some text, and assigns that to a variable. We can even use the input method or function. And by the way, functions and methods are interchangeable. You'll hear me interchange those terms. In essence, they are the same thing. So here we have a function of input, enter your age, and that returns a string value that in the line above we put into username. But now we want to take that string value and convert it to an integer and assign that to a variable called user age. And so inside the argument for the int method is our input function. So it takes a string, converts that to an integer, and returns then an integer and assigns that to user age. Here's another print one where we have a string we're printing, and then we call a string method called format, in which we tell it which values we want to put into the different placeholders of our string. You've learned when we have embedded methods or embedded functions that for every left paren you must have a right paren, so we ought to make sure those count up. We've also imported classes such as the math class and used things like the square root method. So here xyz equals math.square root of 9, and the value of xyz would be 3. Math.square root, passing it the value 9, returns a 3, and that value is assigned to xyz. We also used the randint method for the random class. And so we import random, and then we could say die1 equals random.randint 1, 6, and we're going to get a value between 1 and 6. So we've been using functions all along. We've seen how to use functions. We put arguments inside of parentheses of what we want to pass to that function. But now we're going to make the transition to writing our own functions within our program, or they could be separate outside of our program that would be imported in, just as we imported random and imported math. I'm going to give you an example here of how we'd flowchart some user-defined functions. So we're introducing a new flowchart symbol, which is basically a rectangle with some very narrow rectangles on the left and right, and that is what we would call a sub-procedural call. And so here we're going to have our main program, what we've been writing all along, but it's going to call a function that we're calling print_info. In essence, what's happening is we're going to detour from our main code to this print_info definition and execute that code. So here we would print our source, print our purpose, and then we have a return statement, or in this case, this is a void method that doesn't return anything. It's simply be an end, but it's going to return back. And so we've taken this detour, and now we're going to go back to the main road and continue on. We would get side A and B. And then here we have another detour to a method or function called getHypotenuse. And notice hypotenuse equals getHypotenuse side A, side B. We've gotten side A and side B from the user. Now we're going to pass those values to this method called getHypotenuse and take the A and the B, and we're going to do some mathematical calculations on that. So c squared equals a squared plus b squared. C equals the square root of c squared. And we're going to return, in this case, a value of c back to our calling statement. And c would be assigned to hypotenuse, just like earlier we saw xyz equaling the input of some value. So when we return a value from a method, usually we're going to assign that to a variable of some sort, or use it in some other procedure. We continue on with our main code, and we're going to print the hypotenuse, and then we're going to end. So this, of course, is a method for... Before we look at the code for this, let me talk a little about the benefits of this approach to programming. So it allows us to break our code into simpler and smaller sections. And that makes our code easier to read and easier to debug. It also makes our code reusable. I can take this method for getHypotenuse and I can use it in other programs where I want to get a hypotenuse besides my current program. It's very easy to reuse that. I can even store like methods or functions inside a module and just call that module or import it. It's kind of what we do with the math. We import math. We're importing a bunch of functions that are grouped together in the math module. I can also do unit testing. I can test each one of these methods by themselves and make sure they work. And typically you're working on a larger program, you're working in a team environment and you're going to collaborate. And so if there's, say, 3 of us that are building this program together, one person could do all the main programming, but then they're going to assign this print info method to a second person, and maybe they get hypotenuse to a third person. Or these could be teams, depending on the complexity of the program. So the functions allow us to create blocks that are self-sustaining. We can think of these as black boxes. So let's take the math.square root. Built into Python is the math module that contains the math square root method, and the method contains all the code to take the value that's passed to it. In this case, we're going to pass it 100, and it's going to return a value of 10.0. So it takes a floating point value inside the parentheses as an argument. It receives that in math.square root as a parameter and then works on that parameter to calculate what would be the square root, and then returns or outputs that value back to the calling statement. All we need to know in executing that math.square root method is what kind of value do we need to pass to it and what does it return. We don't care about what's the code that makes that work. That's the black box part. Well, let's take a look at how to do this in this example that I provided of finding the hypotenuse for a right triangle. So we're going to create our functions using the def command for define, and it's sort of like creating a conditional. So I have def print info, that was my one method up here, and all I'm doing here is printing 2 statements. And these are multi-line statements, but the first one basically prints the source, who created this, and for what purpose. And then the next one defines really what it does. What's the purpose of this program? And this project demonstrates the creation and use of user-defined functions. We're going to return a value, and we have a void function. So this particular function, which does not return a value, is called a void function. Whereas the getHypotenuse method returns a value. Here it's going to return C given A and B, C being the hypotenuse. So that's the difference between a void function and a function that returns a value. Then I have another function after that called getHypotenuse. The values inside the parentheses are parameters. And I'm going to take those values and use those in my calculations. So C squared equals A squared plus B squared. And I could have said side C equals math.square root of C squared. Or in this case, I simply said size C equals C squared taken to the power of 0.5. So if you take something to half power, it's the same as doing a square root. And then I have this return statement, return side C. That's what's going to be returned back to my calling statement. Now, because Python is a interpreted language at runtime and not a compiled language, we have to create all of our functions before we call them. At this point, our program doesn't do anything. We have to call these functions to have them do something, and that's where my program actually starts down here. I'm going to call print info. And so when it hits this statement, it's going to come up here and find my function called print info and execute that code, which is my 2 print statements. When that's done, it comes back, and now I'm going to get input from the user on what's the length of side A and put that into a float value and do the same thing for side B. And then I have a variable called hypotenuse, which equals getHypotenuse. I'm going to pass it side A and side B. So when it hits this statement, it goes and finds that method definition, here defining getHypotenuse. It's expecting 2 values, A and B. So side A becomes A, and side B becomes variable B for that method. And then we calculate side C based on those 2 values, and we return side C back to my method, which in essence replaces this with side C and assigns that value to hypotenuse. And then I have a print statement that says given sides A and B, are the two sides. The hypotenuse would be, and then a third value, and I'm formatting side A, side B, and hypotenuse. Let me just run this. And so here then is my program. So I already executed the print info method and printed my two strings that I wanted, or two paragraphs in essence. I'm going to enter side A, and if I just enter a 3 and side B being a 4, we should get 5 as the hypotenuse, and that's what we get. So what happened here was after I entered side A and B, it passed side A as being 3 and side B as being 4 to the A and B and used those in the calculations up here, and then returned side C, and side C was the hypotenuse value that's printed out. Most Python programmers prefer, though, to have everything in a method, including the executable part of our program, which was this. And so what they'll do is they will put this into a method called main, and we'll indent all these statements underneath the definition of main. And then our execution is really just calling main. Let me run this again. And this time I'll do 6 and 8, and we'd expect a value of 10, and that's what we get. So what's happening here is we have these definitions declared, but when I call main, it then executes this one, which also calls the print info and calls the get hypotenuse. Now in most cases, you're going to see that we want to have the main as the initial definition. And that's easier. You're writing your main program, and then as you see, okay, I need a print info, I can create that definition below that. I can create the get hypotenuse definition below that, and so forth. But remember, all of the definitions have to occur before you call them. Your main calling statement should be at the very end of the program. In the next few videos, we'll explore the idea of passing values, of void functions, and functions that return values, and show a few more examples of how to do this. If you just jumped into this video and haven't seen the prior videos to this, I invite you to check out my Python playlist of videos. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.